Hey guys, back with another video. In this one, we will look at the second question from the 2023 MIT Integration B qualifying exam. We have the indefinite integral of the hyperbolic secant of x dx. And I would like to invite you to take a couple of minutes and try to solve this if you haven't already. If you get it, then great. If not, that's fine too. But without further ado, let's get started. So, we see the hyperbolic secant, not very common. It's probably one that we're not very familiar with. But one thing that I do with at least my hyperbolic trigonometric functions is I don't worry about becoming too familiar with all of the properties and whatnot of all of the hyperbolic secants and cosecants and cotangents and whatnot. I mainly just memorize a couple of properties for the sine and the cosine, and then I use those to be able to derive the information that I need for the rest of the hyperbolic trigonometric functions. So what I know is I know that hyperbolic sine of x is equal to e to the x minus e to the minus x over 2, and I know that the hyperbolic cosine of x is equal to e to the x plus e to the minus x over 2. In fact, it is the average of e to the x plus e to the minus x. And I also know that secant, the hyperbolic secant of x, just like secant of x, is equal to 1 over the hyperbolic cosine of x, which means that this will equal 1 over e to the x plus e to the minus x over 2, which means we can just flip it around, and this would equal 2 over e to the x plus e to the minus x. So we can rewrite this integral, and we now have the integral, and I will pull the 2 out to the front. So we get dx, and this is over e to the x plus e to the minus x. So what we can do now is we can realize that we have this e to the minus x, and if we were able to get rid of that and just have everything in terms of positive powers, I think it would be a whole lot easier for us to be able to move forward. So what we'll do is we will multiply the top and the bottom by e to the power of x. So multiply the top and the bottom, and what we get is 2 times the integral of e to the x on top, and then for our denominator, we get e to the x times e to the x, which is e to the 2x. We will add the exponents, and now if we add the, and I will make a better x and a plus sign there. So now if we multiply e to the minus x and e to the x, well, we add the exponents, and minus x plus x is equal to 0, and e to the 0 is 1. So we get 1 then dx. So now, well, if we use our e to the x to be our u, and we do a u substitution, then we get u is equal to e to the x, and du is equal to e to the x dx. Well, this e to the x dx is found in our integral, so we can replace it. So we have 2 times the integral of du over, well, e to the 2x is equal to e to the x squared times itself. So this would be u squared plus 1. Now, if you recognize this is actually the formula for the arc tangent of x. So this would equal, well, actually without the 2 it is, so this would equal 2 times the arc tangent of u plus c. Now if we plug in our u, we get the final result, which is 2 times the arc tangent of e to the x plus c. Well, that was a rather quick one, and just for future reference, if you ever get a little bit confused by a strange looking hyperbolic trigonometric function, see if you can simplify it using some information that you have already memorized, and I would suggest memorizing these two formulas, the hyperbolic cosine and the hyperbolic sine. And normally you can use one of those two formulas to be able to simplify your problem. Well, I hope you found this video helpful. I will be covering the remaining 18 problems from this exam in future videos. And if you have any questions, leave a comment below. I will be sure to respond, and I will see you soon.